Hello YouTubers. In this video I'll continue doing my analysis of UFO data. In the last video I ran a MaxEnt model of the UFO and bioclim data without removing correlated variables. In this video I'll show you how to easily remove correlated variables using R and run a new MaxEnt model with the correlated variables removed. Then I'll compare the new model with the previous MaxEnt model. In R, assuming the correct packages are installed, correlated variables can be removed easily with just 4 lines of code. You should have the raster and USDM packages installed already. All the raster images need to be in a folder, and then a grid can be created of the file names. Since the files are TIF images, make sure to include the pattern argument when listing the files. This is the first line of code, shown in the upper left corner. Once the files are listed, a stack of raster images is created using the raster stack function. Then the USDM library is loaded. This could have been the first line of code just as easily. Then the VIF function is run on the stacked raster images. If done correctly, the output will list all the rasters with their associated VIF values. VIF values are easy to interpret. Lower values mean less correlation. A VIF value of 0 means that the raster has no correlation with the other rasters. Raster images with a value higher than a specified VIF should be removed. In most cases, I think 10 is the cutoff, but it depends on the data set. In this case, there are a number of exceptionally high VIF values, and only 2 variables are lower than 10. So I decided to up the cutoff value to 20. In short, the values are slightly correlated, but nothing significant. As you can see, Bio 3, Bio 8, Bio 9, Bio 15, and Bio 18 should be kept for running the MaxEnt model. After removing the other variables, I opened ArcMap and converted the TIF data into ASCII format so that it could be accepted as input into the MaxEnt software, following the same procedure outlined in the previous videos. The analysis of omission and commission produced good results, as shown by the closeness of the test and training data to the predicted omission. What's perhaps most important to note is that the ROC values are very good for this model, even after removing the correlated variables. The training data produced a 0.863, while the test data produced a 0.862, with 0.5 representing random prediction. Here's a picture of the probability distribution map created. Redder areas show higher probability, while bluer areas show lower probability. The response curves and analysis of variables is where things get a bit interesting. Since correlated variables are removed, it's now much easier to interpret the data. The analysis of variable contribution shows that isothermality is the most important variable in describing UFO sightings, followed closely by mean temperature of driest quarter, representing 42.1 and 37.8% respectively. This indicates that variation in temperature of dry conditions plays a significant role in UFO sightings. The jackknife seems to confirm that isothermality and mean temperature of driest quarter are the most important variables in explaining the model, as they have the longest blue lines. Well, that's all I have for this video. Your support encourages me to continue doing videos like this, so please, if you liked it, please show your support by subscribing. Thanks for your time.